how would I set this up? Without even looking at the picture. But we will consider what this actually looks like after we're done, okay? Just by looking at this, I can see that some of these have variables in them and some of them don't, right? So if they don't have any variables in them, it's safe to put them on the outside. Okay, so just by seeing this, I know that I should put x dx should be on the outermost part of this integral, all right? So when I set this up, I'm going to put dx as the last thing I do, because it just goes from constant to constant, 0 to 1. And then I look through these bounds some more, and I say which one has the least number of variables involved in the bounds. Well, it's this one. See, this one only has an x in the bound. This one has an x and a y. So this one is the next most simplest range of values. So it's going to go next. So my y is going to be the next thing I integrate. And those bounds are 0 to x. And then the most complicated one is the z. So that's the one I should put on the inside. And it goes from 0 to 5 minus x minus y. So that's how I would set this one up. Kind of put the simplest stuff on the outside, the most complex stuff goes on the inside. If two things were equally as simple, you could put them in either order. It doesn't matter. Look at what's happening. The x is going from 0 to 1. All right, so x is going from 0 to 1 over here. Oh, off the screen. Y, now, so once I've specified an x, y is going from 0 to x. Okay, so what's the line y equal x look like? Well, it's a line that kind of comes down this way. So for each x in here, y is going from here to here. So I can see what I'm doing. So at the base of this region that I'm dealing with looks like this. It's this thing. And then once I've specified x and then y, I'm going to find myself somewhere in here. I've got z. Z is going from 0 to this. Well, this defines a plane. All right. So in fact, I can see when I plug in x and y, I get equals 0, I get 5 for z. So actually went over here. I know it intersects the z-axis at 5. So let me just say it's some kind of flat surface up here because it's a plane. So my region is, my volume is probably going to look like this, something like this. I may have it angled in the wrong direction or something like that, but this is the rough idea. So for each fixed x and y, I'm going to integrate in the z direction until I hit this surface. So I'm going to go from 0 up until I get to that height. And this height depends on both x and y, because depending on where I am in here, I have a different height that I have to go. So I can kind of get an idea of what it looks like just by reading these off. So how are we going to set up this integral? Okay. Well, which one has the simplest bounds? It's the one with the x, right? So again, for this problem, I want the x integral to be on the outside. So my outermost one is x. And then what's the one with the next simplest one? It's the y. It's only got one variable in its bounds. So then I would do y. And then the one that's got the most complicated bounds is the z. So it looks like it's dz, dy, dx again. And it's just based on which bounds are have the most variables in them, right? Now, what does x range from? Well, x goes from -1 to 1. These should always be numbers out here. Y, what does y range from? Well, it goes from -1 minus root 1 minus x squared to positive root 1 minus x squared. And what does z go from? It goes from 0 to 1 minus x squared minus y squared. And that's how I would set up that integral. It might be useful to see what that region might look like. So let's just sketch it out. I think it's good exercise to do that. And it's a good thing to check just to make sure that things are making sense. Maybe I should have thought this through before I drew those axes because I see I have to go back out here this way. And y is going to have to, I'm going to have to go out in this direction a little bit. Okay, so I see that x is going from -1 to 1. So x is ranging from here to here. Y is ranging from this value to this value, right? So these should look familiar. You should recognize what graphs these are. This comes from the unit circle. If you solve x squared plus y squared equals 1 for y, you get these two functions, right? So these really just come from the unit circle. So y is going from the bottom half of the unit circle up to the top half of the unit circle. So for each fixed x in between -1 and 1, I'm going from here to here in the y direction. And that's how I'm specifying my x's and y's. Okay. And then for each x and y that I've specified, I'm going to go in the z direction. Now, z looks like it's 1 minus x squared minus y squared. This is a paraboloid opening downwards. It looks like what I'm getting here actually, when x squared plus y squared equals 1, z is 0. So I'm actually getting the paraboloid that actually looks just like this. And so y is going to go from here up until I hit this surface. So I'm really just filling in this bowl-shaped region. And that's the volume that I'm integrating over.